Good evening, dear dreamer, and welcome back to Boring Science for Sleep. It's always a gentle joy to know you're here again, settling under the quiet of night, letting curiosity drift like starlight, and allowing the vastness of the cosmos to soften your thoughts as you rest. Tonight, we turn our gaze toward an idea that feels almost like a mirror, or perhaps a shadow reversed. You've heard of black holes, the devourers of the universe, where gravity becomes so strong that nothing can escape, not even light. But what if there were another side? What if, instead of swallowing, the cosmos could also spit back? Physicists once gave a name to such a thing: a white hole, a strange sibling to black holes, imagined not from observation but from mathematics, a place where nothing can enter, only leave. A fountain of matter and energy pouring outward, the other half of a cosmic equation. No one has ever seen a white hole. They may exist only in the language of equations, fleeting solutions to Einstein's great description of space-time. And yet, the thought of them lingers, haunting and luminous. A star that does not collapse inward, but bursts outward forever. As you breathe slowly tonight, let this thought rest beside you. The universe may contain not only abysses, but also fountains. Not only endings, but beginnings. Black holes remind us of finality. White holes whisper of renewal. So, dear traveler, let yourself grow still. Feel the pull of gravity soften into calm. And as we drift into this story, we'll ask the quiet question together: can the cosmos truly unleash a white hole? The story of white holes does not begin with a telescope, or with the glimmer of light caught on photographic plates. It begins, instead, with lines of mathematics, symbols drawn on paper, equations written in ink, the quiet language of relativity. In 1915, Albert Einstein introduced his general theory of relativity, a grand vision of how gravity truly works. No longer was it a force acting at a distance, as Isaac Newton had described centuries before. In Einstein's view, gravity was the bending of space and time themselves. Mass told space-time how to curve, and curved space-time told mass how to move. It was a beautiful picture, but also one filled with complexity. Einstein's equations were not like simple algebra. They were vast, non-linear, capable of producing solutions far beyond intuition. The equations described not only our ordinary world, but also hinted at extreme possibilities, strange landscapes of space-time that could exist if conditions were pushed far enough. In 1916, just a year after Einstein's publication, a German physicist named Karl Schwarzschild found one of the first exact solutions to the equations. It described the gravitational field around a perfectly spherical mass. At first glance, it looked like the familiar pull of gravity, but hidden inside the math was something more startling. There was a place, a critical radius, where the equations broke down. This was the birth of the concept we now call the black hole. At the time, even Einstein himself doubted such objects could exist physically. The mathematics allowed them, yes, but the universe seemed too orderly, too restrained, to produce such extremes. Still, the equations were there, whispering of possibilities unseen. As decades passed, physicists probed these equations more deeply. They found that the Schwarzschild solution described not only a black hole, a region where nothing could escape, but also, mathematically, its opposite. If one extended the equations in a different direction, mirrored in time, a second solution appeared. Instead of a region from which nothing could get out, there was a region into which nothing could get in. Matter could emerge, light could stream outward, but nothing could ever cross inward. This mirror image solution was named a white hole. It was, in some ways, a mathematical ghost, a reflection of the black hole's abyss. Where the black hole devoured, the white hole erupted. Where the black hole ended time, the white hole seemed to reverse it, spilling out matter as though rewinding the cosmos. Physicists are cautious. They know that not every mathematical solution corresponds to reality. Equations can describe imaginary landscapes just as easily as real ones. But the idea of a white hole lingered, because it felt like the other side of a coin. If nature allowed one extreme, the crushing density of a black hole, might it also allow the opposite? The early decades of relativity were filled with such strange explorations. Wormholes, time warps, universes within universes, all spilled from the equations like dreams from a mathematician's pen. White holes joined this gallery of exotic possibilities, a sibling born not from observation, but from the raw potential of mathematics. And here is where the poetry begins. Think of it. A star collapses under its own gravity, folding inward, vanishing into a black hole. All paths lead inward, none outward. But on the other side of the mirror, imagine instead a star that cannot be entered, only exited. A region from which streams of matter and light forever flow, with no cause we can see, no entrance we can cross. A fountain where physics runs backward, where time itself seems reversed. This was the birth of the white hole, not in the night sky, but in the mind. Not in photons captured on glass, but in equations scribbled on chalkboards. And yet, even at its birth, the white hole was elusive. Physicists wondered, could such things exist? If they did, why had we not seen them? Would they be stable, or would the faintest disturbance collapse them back into ordinary space-time? The questions were deep, and the answers uncertain. The white hole seemed less like a prediction, and more like a riddle, a mathematical curiosity that asked us to think about the universe in new ways. For you, resting here tonight, there is comfort in this story, because it reminds us that not all discoveries begin with sight. Some begin with thought, with the willingness to follow an equation wherever it leads, even into the strangest territories. The white hole is one such path, an invitation to imagine what lies on the other side of gravity. Picture it now, as softly as a dream, a star-like point in the sky, not pulling, but pushing. Light does not fall into it, but radiates outward, endlessly, unstoppably. It is a cosmic spring, not a cosmic sink, a place where beginnings happen, not endings. Even if such things never exist in the flesh of the universe, they exist in its mathematics, and in our imagination, that is enough. The story of white holes began with Einstein's equations, with Schwarzschild's solution, with the willingness to look at symbols and see worlds. It began with the recognition that space-time is more than a stage. It is a living fabric, capable of shaping realities we might never witness, but can still dream. And so, the white hole was born, a child of mathematics, a ghostly twin of the black hole, a whisper of what might be possible when the universe turns its equations inside out. But what is a twin without its sibling? To understand white holes, we must also return to the black holes that inspired them, to the shadows in the sky that swallow light itself, and the reason physicists imagined their opposites in the first place. In the next part of our journey, we'll wander into the depths of black holes and see why their very existence called forth the idea of white holes, the strange inverted mirrors of the cosmos. If white holes are the mirrored dream, then black holes are the undeniable reality. To understand why physicists ever thought to imagine their opposites, we must first sit quietly with the shadows themselves, the black holes that swallow light. A black hole is born when matter collapses under its own weight. A massive star, having burned through its fuel, no longer has the pressure to fight gravity. Its core implodes, crushing inward. The collapse deepens until density becomes infinite, or nearly so, and space and time themselves are pulled into a region from which nothing can escape. Around this region lies the event horizon, a boundary that marks the point of no return. Cross it, and you are lost. Even light, the swiftest thing in the universe, cannot flee. This image of an invisible abyss, swallowing all, captured the imagination of scientists and poets alike. Black holes became the symbol of finality, of endings, of inevitability. They were the universe's great sinkholes, where existence itself seemed to vanish. And yet, the mathematics of relativity offered something curious. Black holes were not static tombs. Their equations contained symmetries, reflections, hidden passages. When extended, the same mathematics that described the inward pull of black holes also described outward fountains of energy, white holes, their inverted shadows. Why did this happen? Because Einstein's equations do not prefer one direction of time over another. To the math, the arrow of time is reversible. If one solution describes collapse, matter falling inward, light captured, then another solution describes the opposite, matter exploding outward, light escaping forever. The black hole has a shadow twin, a white hole, not because we saw it, but because the math allowed it. Think of it like this. Imagine a film reel of a collapsing star. Play it forward, and you see the birth of a black hole. Now, rewind the film. Play it backward, and the star is not collapsing but exploding outward, matter spewing in reverse, a region into which nothing can enter, only escape. That backward film is the essence of a white hole. Of course, films are easy to reverse. Nature is not. Time, in our lived experience, flows in one direction. Entropy increases. Eggs break but do not unbreak. Candles burn but do not unburn. Black holes fit this arrow of time. They swallow, they do not spit out. White holes defy it, making them feel unreal, unnatural. And yet, the symmetry remained in the equations, quietly insistent. It is this symmetry, the mirror logic of relativity, that gave rise to the idea of white holes. For physicists, it was both tantalizing and troubling. If the equations permit them, do they exist? Or are they merely ghosts of math, artifacts without reality? To answer that, one must consider what black holes meant to science at the time. For decades, they too were seen as mathematical oddities. Einstein himself doubted they could be real. It was only through observation, stars orbiting invisible companions, gravitational waves from merging black holes, the direct image of a glowing event horizon, that black holes became undeniable. What if white holes were on a similar path waiting for evidence? And so the idea lingered. If black holes were real, perhaps their opposites were not entirely impossible. Perhaps, somewhere, the cosmos had carved out not just sinks but springs, not just endings, but beginnings. The shadow of the black hole thus gave birth to the dream of the white hole, where one consumed, the other created, where one trapped, the other expelled. They were twin concepts, bound together in thought, even if only one had stepped into the light of evidence. For you, resting now, there is a comfort in this duality. The universe, it seems, loves opposites, matter and antimatter, positive and negative, north and south, light and shadow. Perhaps black holes and white holes too belong to this pattern, paired ideas that give balance, even if only in imagination. Picture it now, a black hole, dark, silent, invisible, swallowing everything. Its event horizon glows only from the matter falling in, never from within. Now flip the image. A white hole, bright, radiant, spewing streams of light and matter but impenetrable from outside. The two stand as mirrors, each defining the other, like inhale and exhale, night and day. Even if white holes are only thought experiments, their existence in our imagination enriches the way we see the cosmos. They remind us that every shadow has its possibility of light, that every abyss carries the dream of escape. The shadow of black holes led us here, not by observation, but by reflection. They were so extreme, so absolute, that the mind could not resist asking, if this is possible, what is its opposite? That is the heart of white holes. They are not predictions of what is, but explorations of what might be, if the universe chose to play both sides of gravity's coin. And so, the shadow taught us the dream. From the darkness of black holes, we imagined fountains of light. From the certainty of collapse, we imagined eternal release. From the silence of endings, we imagined beginnings. This is the gift of white holes, not their reality, but their invitation to wonder. But to imagine white holes is to imagine time itself running in reverse, an unfamiliar current, where cause and effect blur, and matter is expelled instead of drawn in. In the next part of our journey, we will explore this strange reversal, and ask, what would it mean for the universe if time itself could flow the other way? Time, to us, feels like a river flowing only one way. We wake, we live, we age, we sleep. A glass falls, it shatters, and the pieces do not leap back together. A candle burns, wax melting, smoke drifting upward, and no matter how long we wait, it does not unburn. This arrow of time is so natural to us that we rarely question it. Yet deep in the mathematics of relativity, the equations do not pick a direction. They allow both forward and backward. This is where the white hole enters the picture. A black hole is time's arrow pointed forward with terrible certainty. matter falls inward, energy is swallowed, light itself is trapped. There is no escape, no reversal, only the future, everything drawn deeper toward the singularity. But a white hole is the same equation flipped backward. In it, nothing falls in. Instead, matter and energy pour out, unstoppable, as if the film reel of the cosmos were running in reverse. Imagine, for a moment, watching such a reel. A black hole's birth begins with collapse, a massive star folding in on itself, shrinking, its core crushed into oblivion. Play that backward, and what do you see? A singularity erupting into matter, space expanding outward, fragments of energy spilling in every direction. That backward picture is the white hole, the anti-collapse, the cosmic outbreath. Of course, the mind resists. How can anything exist that refuses entry? How can a region of space-time repel everything when we are so used to gravity drawing things inward? A white hole would be like a mountain too steep to climb, not only steep, but inverted, pushing you away the closer you came. Try to fall in, and the universe itself would push you back. If black holes are prisons, white holes are fountains. They do not allow capture, only release. This reversal creates strange images. A black hole devours matter, gas, dust, stars. A white hole ejects matter, streams of light, jets of particles, entire clouds flung into space. A black hole marks the end of time for anything crossing its horizon. A white hole, if it existed, would mark a perpetual beginning, an endless eruption that cannot be stopped. Some physicists have even wondered if the Big Bang itself, the moment our universe began, could be thought of as a kind of white hole, a singularity that did not swallow but exploded outward, giving birth to all matter and energy we see today. In that picture, our entire cosmos is what happens when time runs in reverse, when collapse turns into expansion. But here, imagination must tread carefully. For while mathematics permits such reversals, nature resists them. Our arrow of time is anchored by entropy, the tendency of order to unravel, of energy to disperse. A white hole, by its very nature, seems to deny entropy. It runs the movie backwards. It suggests eggs unbreaking, smoke unrising, stars uncollapsing. It is difficult to reconcile with the laws we know. And yet, as a thought experiment, it holds power, because it reminds us that the universe is not limited by our habits of thought. It suggests that somewhere, in the vast and strange possibilities of space-time, there may be phenomena that feel like time reversed, if not in literal physics, then in metaphor, in the ways we interpret beginnings and endings. Picture it now, a region of the sky, silent, empty. Suddenly, light bursts outward, scattering like fireworks. Gas clouds radiate away, energy streams into the void. Nothing falls in, no dust, no stars, no light, only out. It is as if the universe itself has chosen to exhale, a single point releasing what has been hidden. That is the dream of the white hole, a place where the future is always release, never capture. For you, drifting toward rest, this reversal can be soothing. We are so used to endings, black holes, collapse, the closing of time. But white holes remind us of beginnings. They are the eternal dawn, the perpetual spring, the infinite outpouring. They whisper that, even in the deepest equations, the cosmos holds space for renewal. And perhaps that is why they matter, even if they are never found. They balance the black hole's grim finality with the dream of release. They show us that time might not be as one-directional as we think. They remind us that physics is not only about what we see, but about what we can imagine. In the end, a white hole may be nothing more than a ghost of mathematics, a reflection of equations extended into realms where reality cannot follow. But even as a ghost, it comforts us. Because it tells us, for every sink, there is a source. For every collapse, an expansion. For every shadow, a light. And as you breathe slowly, feel your chest rise and fall, you can think of yourself as a tiny mirror of this cosmic rhythm. Inhale, the black hole drawing inward. Exhale, the white hole releasing outward. In that simple cycle, the universe whispers its balance. The white hole is time reversed, the cosmos exhaling instead of inhaling, the fountain instead of the prison. Whether or not such things exist, Their presence in thought gives us a new way to see the sky, not as a finished story, but as a tale that can run both forward and backward, collapse and expansion, end and beginning. But dreams are one thing, reality another. If the equations permit white holes, why don't we see them? Could the universe truly sustain such objects, or do they collapse under the weight of their own impossibility? In the next part of our journey, we'll ask, can they exist at all, or are they destined to remain only on paper, fragile as chalk on a blackboard? Equations are generous dreamers. They open doors to possibilities the universe itself may never walk through. Among the solutions to Einstein's equations, black holes stepped from paper into the sky. We have seen their shadows, felt their gravitational waves, traced their effect on stars. But their mirrored siblings, the white holes, have remained in hiding. The question is simple but heavy. Can they exist? At first glance, the answer seems to lean toward no. White holes are unstable by design. Think of a fountain of light and matter pouring outward, endlessly. If even a single particle were to drift inward, dust, gas, the faintest ripple of gravity, it would break the perfect symmetry that defines a white hole. It would collapse the delicate structure back into something else, most likely a black hole. Unlike their devouring twins, which grow stronger by swallowing, white holes would be fragile, destroyed by the very act of being touched. This fragility makes them seem improbable. The cosmos is messy. Space is filled with dust, gas, wandering photons. There is no perfect vacuum where a white hole could sit undisturbed. In such a universe, how could anything so delicate survive? There are other struggles too. A white hole seems to run against the flow of time itself. Entropy, the great law of disorder, pushes forward. White holes demand it run backward, like a broken cup reassembling, like smoke returning to a candle. Such violations are not impossible in equations, but in reality, they challenge the foundations of thermodynamics. And yet, physicists do not let go so easily. For while the universe may be harsh on impossibilities, it also has a history of surprising us. Black holes themselves were once dismissed as mathematical fictions. Nature abhors such singularities, Einstein wrote, and yet they are real. Could white holes be waiting in some hidden corner of reality beyond our current vision? Some theories suggest that white holes might not exist as standalone objects, but as fleeting phenomena, tiny bursts in space-time, appearing briefly, expelling energy, and then collapsing. These would not be permanent fountains but cosmic hiccups, rare and brief, too fast for us to catch. If such events exist, they may even hide in the data we have already collected, disguised as sudden flares or unexplained bursts of light. Others link white holes to black holes in a more intimate way. According to certain solutions, the interior of a black hole might connect to the birth of a white hole somewhere else, or someone else. Matter falling into the abyss could, in theory, erupt from another horizon, emerging as if from the other side of time. This idea is speculative, wrapped in paradoxes, but it fascinates. It suggests that endings may be beginnings, and that black holes and white holes are not separate, but parts of one cosmic cycle. And then there is the boldest speculation of all, that the Big Bang itself was a white hole, the universe, erupting from a singularity, expanding outward, light and matter spilling in every direction. From this perspective, our entire cosmos is a white hole, the ultimate fountain, still pouring forth. If so, white holes are not rare, they are our origin. But speculation is not proof, and proof has remained elusive. Telescopes scan the sky, and what they find are black holes, quasars, supernovae. They find collapse and explosion, devouring and shining, but never the clean, impossible fountain of a true white hole. Perhaps this is because white holes cannot persist. Perhaps they are too fragile, too unstable. Or perhaps they exist only at scales and times we cannot reach, at the birth of universes, or in the hidden folds of space-time where we cannot look. For us, drifting in the quiet of night, this struggle is soothing in its own way, because it reminds us that science is not a ledger of certainties, but a dialogue between what is possible in thought and what is possible in nature. White holes show us the gap between math and reality, and that gap is fertile ground for wonder. Picture it. a blackboard filled with chalk marks, equations sprawling like constellations. Within those marks lies the possibility of white holes, fragile and luminous, fountains in the fabric of space-time. Whether or not the universe grants them existence, they live in our minds, in our questions, and perhaps that is their truest home. As you rest, let the paradox comfort you. A white hole is both impossible and imaginable. It is ruled out by entropy, yet whispered by relativity. It is fragile to disturbance, yet resilient in thought. It may never exist in the sky, yet it exists in us, in our willingness to dream. The struggle with reality is not a failure, it is the essence of science. We ask, we imagine, we test, we discover what holds and what fades. And in that process, even ideas that do not survive enrich us, reminding us that the universe is stranger than we know, and perhaps stranger than we can know. So sleep now with this thought. The cosmos is filled with possibilities, some real, some ghostly. White holes may be no more than a mirage of mathematics, but even mirages can guide wanderers across deserts, pointing the way toward truths not yet reached. But if white holes struggle to exist in isolation, perhaps they can survive in companionship, with wormholes, with black holes, with the exotic geometries of space-time. In the next part of our journey, we will explore these connections, how white holes have been imagined not only as fountains, but as gateways, doorways into other realms of the cosmos. When imagination touches equations, doorways begin to open, and few doorways in the cosmos are as tempting as wormholes, those tunnels in space-time that connect distant points, or even different universes. White holes have often been woven into these speculations, not as solitary fountains of light, but as portals, paired with black holes to form cosmic gateways. The idea of a wormhole came, like the white hole itself, from Einstein's equations. In 1935, Einstein and his colleague Nathan Rosen found that space-time could, at least on paper, fold into a kind of bridge. Their model became known as the Einstein-Rosen bridge, a tunnel connecting two regions of space. At one mouth of the tunnel was a black hole, an entrance into the abyss. At the other mouth, in the mathematics, appeared its mirror, a white hole, endlessly ejecting what the black hole consumed. This pairing had a strange beauty. A black hole devoured, a white hole expelled, and between them stretched a tunnel, a passage through the fabric of reality. Fall into the black hole, and, in theory, you could emerge from the white hole carried across the bridge. It was an elegant symmetry, a vision of balance, every sink paired with a source, every end with a beginning. Of course, reality resists such perfection. Wormholes, as Einstein and Rosen conceived them, collapse too quickly for anything to cross. Their tunnels pinch shut, unstable, fragile as soap bubbles. Yet the dream remains, reshaped and reimagined by generations of physicists and storytellers alike. In science fiction, wormholes and white holes became gateways for travel, shortcuts across galaxies, passages to parallel worlds, bridges to the unknown. In stories, ships dive into black holes and burst out of white holes light years away. Entire civilizations imagine highways of space-time, stitched together by these exotic twins. In physics, the story is subtler. To hold a wormhole open, exotic matter with negative energy might be required, substances we have never seen, but which equations permit. If such matter could exist, then perhaps a black hole could indeed connect to a white hole, their horizons forming mouths of a tunnel through space-time. The connection between black holes, white holes, and wormholes is tantalizing because it offers a kind of narrative. Black holes feel like endings, inescapable, final. White holes feel like beginnings, outpourings, renewals. A wormhole unites them, creating a cycle. What enters one end may emerge from the other. Instead of abyss and fountain standing apart, they are linked, complementary two halves of a greater whole. Some theories take this further, suggesting that every black hole might secretly hide a white hole on the inside, that what falls into one end of space-time could eventually erupt from another place entirely. In this view, white holes are not absent from the universe. They are simply hidden, tucked away beyond horizons, unreachable, but implied. And then comes the boldest speculation. Perhaps the Big Bang itself was the mouth of a white hole. Imagine it. Somewhere in another universe, matter collapses into a black hole. On the far side of the bridge, that matter erupts outward as a white hole, creating a new cosmos. Each black hole births another universe, each white hole an expansion. In this picture, our universe is not singular, but one of countless children born from the fountains of others. These ideas are speculative, fragile, perched on the edges of physics, and yet they serve a purpose. They remind us that science is not only about what we know, but about what we dare to imagine. Even if wormholes and white holes remain mathematical fantasies, they stretch our minds, invite us to see the cosmos not as static, but as full of hidden connections. For you, lying in stillness tonight, this is a comforting thought, that beyond the stars you see, there may be bridges unseen. That the universe may contain not only distances but shortcuts, not only collapses but renewals, not only endings but beginnings. The white hole becomes not just a fountain, but a doorway, a symbol of possibility. Picture it softly, a black hole, dark and silent, its event horizon glowing faintly with falling matter. Across space-time, its twin, a white hole, radiant, spilling light, untouchable. Between them stretches an invisible tunnel, curving through dimensions we cannot see. You fall into one and emerge from the other, reborn in a distant place, a distant time. Whether this is real or only dream, it soothes, because it suggests that nothing is truly final, that there are always other paths, other horizons. Wormholes and white holes may never be seen. They may remain forever in equations and stories. But in those equations, they exist, perfect symmetries, balancing black and white, sink and source, night and dawn. And in our stories, they exist even more vividly, carrying us across the stars in moments, stitching together the galaxies with threads of possibility. Perhaps that is their true gift, to remind us that the cosmos is not only vast but imaginative, that the universe itself, through the equations of relativity, invites us to dream of doorways, and that, even if we never walk through them, the dreaming itself expands us, making the night sky feel alive with possibility. As your eyes grow heavy, think of those bridges. Think of white holes not just as fountains of light, but as gateways, silent, unreachable, yet luminous in thought. They are the symbols of beginnings on the far side of endings, the gentle reminder that collapse may give birth to expansion, and that the universe holds mysteries beyond measure. But wormholes and gateways are only one thread of the story. Another speculation takes us even further. What if the greatest beginning of all, the Big Bang itself, was a white hole on a cosmic scale? In the next part of our journey, we'll step into that thought, the possibility that our entire universe is the eruption of a white hole beyond imagination. When we gaze back through time, following the faint light of galaxies retreating into distance, we reach a boundary. The farther we look, the younger the universe appears. Stars grow fewer, galaxies closer, light more compressed, and at the very edge, we find a moment of origin, the Big Bang, the birth of space and time. For nearly a century, cosmology has treated the Big Bang as the starting line, the great expansion from which everything flowed. But what if it was not only a beginning? What if it was also the echo of something else, an outflow, the eruption of a white hole? The thought begins with symmetry. Black holes swallow, white holes erupt. Black holes pull inward, white holes push outward. When we describe the Big Bang, we use similar words: an outward eruption, unstoppable, uncontainable, pouring matter and energy into existence. In its own way, the Big Bang behaves exactly like the theoretical picture of a white hole. Nothing could fall into it. Everything could only come out. Some physicists have proposed that this is more than a metaphor. Perhaps our entire universe is the inside of a white hole, the far side of a black hole that formed in another cosmos. Imagine it. In some parent universe, a star collapsed, forming a black hole. On the far side of the singularity, space-time curved outward instead of inward, and what emerged was our universe, expanding, cooling, creating stars, galaxies, and eventually, us. This picture, though speculative, has a kind of poetry. It turns the abyss of one universe into the fountain of another. Every black hole, then, might be a seed, its collapse hidden but its explosion revealed in another realm. Our Big Bang would simply be one such seed, blooming into a cosmos. The idea ties together endings and beginnings. What we call death in one place becomes birth in another. The black hole and the white hole are not separate, but two faces of a single event, connected across the fabric of existence. Of course, this is theory, not evidence. We cannot look beyond our own cosmic horizon to see what lies outside. We cannot peer into the singularity of a black hole to watch another universe emerge. The laws of physics, as we know them, bend and break at those edges. Yet even if we cannot see it, the possibility stirs something deep. For you, drifting in the quiet of night, let the image take shape softly in your mind. Imagine the Big Bang not as a sudden, isolated explosion, but as the mouth of a fountain. Matter and energy spill outward, galaxies forming like droplets in the spray. Space itself stretches like ripples in a pond. And at the unseen root of it all lies a white hole, its eruption timeless, its expansion endless. This thought carries a strange comfort, because if our universe is born from a white hole, then we are not only creatures of stars, we are creatures of fountains. Our very existence is the echo of an outpouring, the gift of release. The laws of physics that shape us were carried outward in that first burst, like seeds in the wind. It also changes how we think of beginnings. We often imagine the Big Bang as absolute, a creation from nothing, but the white hole picture suggests continuity. Our beginning might have been another's ending. Our expansion might be the flip side of collapse elsewhere. This ties us into a larger tapestry, a chain of universes giving birth to one another, endlessly, like a cosmic forest, where each tree grows from the falling seed of another. Still, the Big Bang as a white hole remains an open question. The mathematics allows it, but observations are silent. The cosmic microwave background, the faint afterglow of the Big Bang, tells us much about expansion, but nothing about whether it was the mouth of a white hole. The galaxies we see tell us about growth, but not about origins beyond our own horizon. And perhaps that is as it should be. Some mysteries are not walls to be broken, but horizons to be contemplated. To think of the Big Bang as a white hole is not to solve the universe, but to enrich our imagination. It is to see beginnings not as absolute, but as part of a cycle. Expansion following collapse, light following shadow, dawn following night. There is a soothing rhythm in this. You breathe in, you breathe out. The stars collapse, the stars explode. Black holes swallow, white holes erupt. The cosmos itself inhales and exhales, and in that rhythm, life finds its place. So tonight, as you rest, let yourself drift into this thought. You are part of that outpouring. The atoms in your body were born in the furnace of stars, and those stars were born in the expansion of space, and that expansion may itself be the fountain of a white hole. You are, in every sense, the echo of release, the child of a cosmic exhalation. Even if white holes never exist as standalone objects, the image remains. The Big Bang has the qualities of a white hole, unstoppable expansion, irreversible release, and that is enough. Enough to remind us that beginnings are woven into the fabric of reality, that creation is not an exception but a rhythm. So imagine the universe itself, still expanding, galaxies drifting farther apart, stars forming and dying, light stretching thinner, all of it still flowing outward from that first fountain, that primal eruption, all of it still the unfolding of a white hole that may never end. And let that image cradle you into peace. You are part of the fountain, carried outward in the flow, borne along by the quiet current of time. You are the echo of a white hole, still expanding, still unfolding, still glowing softly in the night. But if the Big Bang carries the qualities of a white hole, we might ask, if smaller white holes existed, how would we find them? What signs in the sky would reveal their presence? In the next part of our journey, we'll turn our attention outward, to the search for white holes among the stars, and the question of how we might ever recognize them if they appeared. When an idea exists only in mathematics, the natural question becomes, how would we ever see it? For black holes, we answered that question over time. We learned to notice the dance of stars orbiting invisible companions. We listened for gravitational waves from colliding giants. We even caught a faint shadow of an event horizon, glowing against a ring of light. But what about white holes? If they exist, if the cosmos can truly unleash such fountains, what would their signatures be? At first glance, one might expect a white hole to be obvious. After all, if black holes swallow everything, then their opposites should spew everything out. They should blaze like cosmic beacons, spilling light and matter in endless streams. Yet the sky, in all our searching, has not offered such a spectacle. There is no star that shines with the peculiar defiance of a white hole, no fountain erupting forever in the void. Still, physicists and astronomers have tried to imagine what signs might betray one's presence. One idea is that a white hole would resemble a sudden explosion in space, a burst of radiation and particles erupting outward. But unlike a supernova, which brightens and fades, a white hole's eruption would have no cause we can see, no star preceding it, no collapse to explain it. It would appear as a sudden flare, without history, without warning, as if light had been waiting behind a curtain and then burst free. Some have even suggested that gamma-ray bursts, those powerful flashes of high-energy light that appear randomly across the sky, could be linked to white holes. Most gamma-ray bursts are explained by known causes, the collapse of massive stars or the merger of neutron stars. But what if a few of them are something stranger, tiny white holes, erupting once and then vanishing? This leads to another idea, that white holes, if they exist, might be short-lived. Unlike black holes, which persist and grow, white holes might be fleeting. They could appear as momentary eruptions, release their energy, and then collapse, leaving nothing behind. If so, they would be nearly impossible to predict and difficult to catch, lightning flashes in a cosmic storm, gone before our instruments can focus. Others imagine that white holes might masquerade as ordinary phenomena. Perhaps we already see them, but we interpret them as quasars or flares, explosions or bursts, because we lack the context to call them otherwise. After all, the universe is filled with violent events. To pick out a white hole among them would require not only sharp eyes, but also the courage to ask if something truly new is hiding there. And then there is the possibility that white holes cannot be seen at all. If they exist only as the far side of black holes, if every black hole's singularity connects to a white hole in another universe, then we are trapped in our perspective. We cannot cross the horizon to witness the other side. The white hole may shine, but only into another cosmos, unreachable to us. In that case, searching our sky would be in vain, for the fountains would erupt elsewhere. For you, resting tonight, these speculations are not burdens but lullabies. They remind us that the universe still hides surprises, that even with telescopes scanning every corner of the sky, mysteries remain. Perhaps white holes are rare. Perhaps they are everywhere, unseen. Perhaps they never existed at all, except in equations. Each possibility is a story, and each story deepens our sense of wonder. Imagine, softly, how a white hole might appear if it did erupt in our sky. You would see a sudden bloom of light, brighter than a galaxy for an instant, then fading into silence. Or perhaps you would see streams of particles rushing outward, a fountain with no visible source. Or perhaps nothing at all, only the subtle fingerprints of something strange, written in wavelengths too faint for human eyes. The search itself is a kind of meditation. Astronomers look not only for answers but for questions. They scan the sky for anomalies, things that do not fit patterns, light that does not behave. In every unexplained burst, every odd signal, there lies the whisper, could this be something more? And here is the gentle truth. Even if we never find a white hole, the act of searching enriches us. It teaches us patience, humility, curiosity. It keeps our eyes open to the unexpected. White holes, real or not, expand our imagination of what the universe could be. So as your thoughts drift tonight, let the search itself be the comfort. Somewhere above, telescopes scan the darkness. Somewhere, data flows onto screens, lines of light curves traced across time. Somewhere, astronomers and dreamers alike wonder if a sudden flare, a fleeting burst, might be the sign of a fountain in space-time. And whether it is or isn't, the wonder remains. because the universe is vast enough to hold not only what we see, but also what we dream, and sometimes dreaming is enough. But white holes are not only mathematical puzzles or scientific searches, they have also found a place in our imagination, in our stories, in our symbols. In the next part of our journey, we will step beyond science and into culture to see how white holes have appeared in fiction, in metaphor, and in the ways we dream of beginnings beyond endings. Not every mystery of the cosmos lives in observatories or on chalkboards filled with equations. Some of them dwell in the quiet corners of human imagination, in novels, in films, in the metaphors we create when faced with the unknown. White holes, elusive in reality, have found a rich home in this imaginative space. For scientists, they are fragile, unstable solutions to Einstein's equations, unlikely to ever appear in nature. Yet for storytellers, they are doorways, miracles, or symbols of hope. If black holes have become the language of endings, collapse, and despair, then white holes have become the language of escape, renewal, and beginnings. In science fiction, white holes are often painted as gateways. A starship vanishes into a black hole, only to reappear from a white hole light years away. The logic does not need to be strict, it only needs to feel poetic. One swallows, the other releases. One is entrance, the other is exit. Sometimes they are imagined as weapons, cosmic cannons blasting streams of light. At other times they are beacons, scattering energy into the dark. In some visions, they are cradles of universes, each white hole the birth of a new cosmos, blooming from the collapse of another. But white holes do not live only in fiction, they also survive as symbols in thought and language. A black hole has become part of everyday speech, describing something endless and consuming, a black hole of money, a black hole of time. A white hole, though far less common, suggests the opposite, an inexhaustible source, a fountain that never runs dry, a generosity without end. They can stand for creativity, abundance, and rebirth. Perhaps this is why white holes capture us so deeply. They offer balance. Human beings are drawn to opposites, light and dark, night and day, inhale and exhale. Black holes are real, heavy with evidence, and they stir unease with their inevitability. White holes counter that unease, offering a mirror image, a poetic symmetry, a reassurance that the universe may not only take, but also give. There is also the fascination of the impossible. A white hole is unstable, improbable, almost certainly absent from nature, and yet we dream of them anyway. They remind us that imagination is not bound by physics. In dreaming of white holes, we rehearse hope itself, the belief that something impossible may still shine in thought, if not in reality. And perhaps this is their deepest role, not as physical objects, but as symbols we carry within. Imagine them as fountains of renewal, doors of possibility, beginnings that arrive after every ending. Even if they never exist in the sky, they exist in us, as symbols of release, of light breaking through, of life that continues. Picture a black hole and a white hole, side by side, not in equations but in your imagination. The black hole whispers, all things end, all things collapse, nothing escapes. The white hole whispers back, all things begin, all things flow outward, nothing is trapped forever. Between them lies a dialogue, a cosmic yin and yang, teaching us balance. Perhaps you will dream of a white hole not as a strange star in the heavens, but as a feeling, the sense that renewal is always possible, that after collapse comes release, that even in the dark, there is a quiet promise of light. This is why white holes remain in imagination, because they soothe us with the idea that the universe is not one-sided, that somewhere in the endless night, there are fountains as well as abysses. So as your breathing slows, let that idea become your lullaby, that the universe, vast and mysterious, may not only devour, but also give. That white holes, whether real or not, remind us of beginnings, waiting quietly behind endings. Every mystery in the cosmos is also a mirror. When we study a strange equation, or watch the flicker of a distant star, or imagine something as wild as a white hole, we are not only learning about the universe, we are also learning about ourselves, about the way science is done, and about the nature of curiosity itself. White holes, even if they never exist in nature, have already taught us important lessons. They show us how far mathematics can carry imagination and how carefully reality pushes back. They remind us that science is not a catalogue of certainties, but a dialogue between possibility and truth. The first lesson white holes offer is humility. When Karl Schwarzschild first found the mathematical solution for black holes, even Einstein himself doubted they could be real. They seemed like curiosities, artifacts of the equations, not genuine parts of nature, and yet, a century later, we have seen them, measured their shadows, listened to their collisions. What was once dismissed has become undeniable. White holes sit now where black holes once sat, in the liminal space between theory and observation. Their equations are clear, but their evidence is absent. Science, however, does not rush. It holds space for the unknown, but it does not embrace it too quickly. White holes remind us that even when the math is compelling, reality has the final say. This humility, the ability to say we don't know, is the heartbeat of science. The second lesson is about imagination. Equations are not cages, they are invitations. When physicists saw the solution that described white holes, they did not dismiss it entirely. They let themselves wonder, what if? What if the universe really could have fountains as well as abysses? What if every black hole hid a doorway to another place, another time, another cosmos? These questions may never find answers, but the act of asking expands our vision. White holes are not predictions so much as provocations, pushing us to consider what might be possible at the farthest edges of physics. The third lesson is about the balance of science. On one side is imagination, willing to follow equations into fantastical territories. On the other side is discipline, demanding evidence, refusing to mistake mathematics for reality. White holes live exactly in this tension. They are possible in theory, improbable in practice, and meaningful in thought. Science needs both halves, the daring to imagine and the patience to wait for proof. In this way, white holes teach us that science is not about erasing mystery, but about refining it. When an idea first appears, it may seem like an answer. But over time, as we explore, the idea often becomes more complex, more subtle, more layered with conditions. White holes began as neat mirrors of black holes. Today, they are tangled in questions of entropy, instability, and the arrow of time. They have not disappeared, they have deepened, and that deepening itself is a kind of progress. The fourth lesson is about perspective. Science is not only what professionals do in observatories and laboratories, it is also what we, as humans, share when we wonder about the universe. White holes, like alien megastructures around Tabby's star or life on other planets, show us that part of science's role is to hold questions that ignite the imagination of everyone, not just specialists. When we speak of white holes, we are not only solving equations, we are telling stories about what might exist. These stories belong to all of us. For you, listening in the quiet of the night, this is perhaps the most comforting truth, that science is not a cold machine of facts, but a living practice of curiosity. It is not afraid to dream, nor afraid to admit ignorance. It holds equations in one hand and wonder in the other, and it walks slowly into the dark. White holes are one of those lanterns, dim, uncertain, but still glowing enough to guide thought. Imagine, gently, a room of physicists looking at the equations that describe space-time. Some lean toward skepticism. These white holes cannot exist. Others lean toward curiosity. But what if they do? Between them is not conflict, but conversation. This is science, not certainty, but the willingness to hold many possibilities until the evidence chooses. This lesson extends beyond science itself. In our own lives too, we encounter mysteries, uncertainties, possibilities that may never resolve neatly. White holes remind us that it is not a failure to live with the unknown. It is a practice of patience. To not know is not to be lost. It is simply to be on a journey where the horizon is far. The fifth lesson white holes offer is about hope. Black holes remind us of finality. They tell us that collapse is possible, that endings are inevitable. White holes whisper the opposite, that beginnings might always be hiding on the other side, that collapse might not be the only story, that renewal is built into the fabric of thought. Whether they exist or not, White holes embody the spirit of possibility. They show us that even physics itself dreams of escape. And so, in the gentle rhythm of science, white holes remain, not proven, not observed, not dismissed. They live in the fertile middle where imagination and discipline meet. They teach us to balance dreaming with doubt, to value humility over haste, to treasure questions as much as answers. As you drift tonight, let this lesson soothe you, that science is not about closing every door, but about walking slowly through them. That the universe may always hold more than we can see. That some of its most beautiful gifts are not facts, but mysteries that invite us to wonder. Even if white holes are never real, they are real enough to teach. They are mirrors of our curiosity, fountains in our imagination, symbols of beginnings that balance endings. They are proof that the cosmos is not exhausted, that it can still surprise us, still baffle us, still awaken awe. So rest now, dear traveller. Know that not knowing is not a flaw but a gift. Know that wonder is not wasted but essential. And let the quiet presence of white holes remind you that even the impossible has a place in thought, and that thought itself can be a comfort, as vast and calming as the night sky. But science is not the only lens through which we see white holes. Beyond equations and evidence, they also touch something more human, the sense of wonder and imagination that gives meaning to mystery. In the next part of our journey, we'll step away from the practice of science and into the heart of wonder itself, reflecting on why these impossible fountains comfort us and what they reveal about the human need to dream. Some ideas in science are carried not by evidence, but by wonder. They endure not because we have seen them, but because they remind us of how vast our dreaming can be. White holes are one of those ideas, fragile in physics, sturdy in imagination. They reveal something profound, that even when nature does not confirm our hopes, we still find comfort in the act of hoping. Wonder has always been a partner to science. The earliest humans, staring at the stars, had no telescopes, no equations, no way of knowing what those points of light were, yet they imagined. They spun constellations into stories, shaped myths into maps, gave names and meanings to what they could not explain. That act of wondering was the beginning of inquiry. Without it, there would be no questions, and without questions, there would be no science. White holes belong to that lineage. They are the myths of modern physics, not carved in stone or told by firelight, but written in the quiet symbols of relativity. They do not tell us what is, but they whisper what might be. They are reminders that the universe is more than data. It is also a stage for the imagination. The appeal of white holes is not only in their strangeness, but in their balance. A black hole represents an ending, a final collapse, a silence that swallows everything. It is heavy with inevitability. But a white hole feels like its opposite, a beginning without cause, a release without restraint, a cosmic fountain pouring light and matter outward forever. Together, they form a symmetry that satisfies something deep in us. Endings and beginnings, inhales and exhales, shadows and dawns. Even if we never see a white hole, the idea comforts us because it feels like part of a story the universe should tell. It balances the weight of black holes with the promise of renewal. It whispers that collapse may not be the only song sung in the cosmos, that there may also be fountains, bursts, beginnings without end. This is the power of imagination. It fills the gaps where knowledge falters. It paints images where evidence is silent. It allows us to dream, even when those dreams might never come true. Science often relies on imagination to take its next steps. Equations guide us, but it is imagination that asks the daring questions. What if every black hole is the seed of another universe? What if time itself can run backward? What if renewal is written into the heart of reality? And even if the answers turn out to be no, the asking itself is valuable. Wonder keeps us humble. It keeps us curious. It keeps us awake to the mystery of existence. For you, resting tonight, perhaps this lesson feels familiar. In life, too, we live with mysteries. We do not always know where we are going, or why things unfold as they do. Sometimes, we cannot see the evidence of renewal. Yet imagination comforts us. It lets us believe in beginnings, even when we are surrounded by endings. White holes, whether real or not, become metaphors for that belief. Picture it gently, a starry sky, black holes hidden in their silence, yet somewhere else in the vast unknown, fountains of light erupting outward, unstoppable. You may never see them, yet you can imagine them, and in that imagining, you feel balance, the abyss and the fountain, the collapse and the release, the ending and the beginning. This is what white holes give us, not certainty, but poetry. They remind us that the cosmos is not only made of matter and energy, but also of stories we tell ourselves to find meaning. They are the dreams physics gives us, the modern myths we share, the whispers of fountains hidden in the dark. Wonder, too, is not wasted. Even when it leads to ideas that nature denies, it leaves us richer for having dreamed. It expands the horizon of what we can picture. It comforts us in the face of vastness. It reminds us that knowledge is not the end of mystery, but its companion. As your body grows heavy and your thoughts soften, let this reflection settle in, that imagination is not something childish or disposable, but something sacred. It is the way we touch the infinite without instruments, the way we wander the universe without leaving home. White holes are proof of that, proof that even the impossible has a place in our hearts, and that dreaming itself can be as real a gift as discovery. Perhaps you will never look through a telescope and see a white hole. Perhaps no one will, but when you hear the idea, your mind lights up. You picture fountains of starlight, cosmic doorways, beginnings bursting from the fabric of space. And in that moment, you are part of the same tradition as the earliest stargazers, using imagination to fill the sky with meaning. So rest now, with this thought as your lullaby, that the universe is not only made of what we can prove, but also of what we can wonder. That white holes, fragile and improbable, live on as symbols of hope, and that imagination itself is a kind of light, pouring outward, unstoppable, forever renewing. But every dream, no matter how beautiful, eventually circles back to silence. White holes may never exist outside of thought, yet the lessons they give us, about science, about wonder, about balance, remain. In the final part of our journey, we will let the fountains fade into stillness and reflect on what it means to say goodbye, to let the mystery rest, and to close the night with a gentle goodnight. Every journey must end, even journeys through ideas. We have wandered tonight through the mirrored dreams of physics, from Einstein's equations to the shadows of black holes, from time reversed to fountains of light, from wormholes and gateways to the possibility that our very universe is itself the eruption of a white hole. And yet, as we arrive here, we find ourselves not at an answer, but at a gentle quiet. Because white holes remain what they have always been, ghosts of mathematics, fountains of imagination, whispers in the language of relativity. No telescope has found them. No detector has traced their signal. They are not in the catalogue of the cosmos, only in the margins of our dreams. And that is all right. Science is not a story of every idea being proven. It is a story of questions, of possibilities, of patience. White holes may never exist, but the act of imagining them has already changed us. It has reminded us that the universe is larger than certainty, that our equations can stretch farther than our eyes, and that wonder itself is as important as evidence. So, let us linger here a little longer with this thought. Not every mystery must resolve. Some can remain open, like windows, onto the infinite. White holes are such windows, ideas that invite us to lean out over the edge of knowledge, to see what might lie beyond, even if we never step through. Picture it gently as you lie here, a sky filled with stars, some collapsing into silence, others bursting into fire. And somewhere, perhaps only in imagination, a fountain, light pouring outward, endless, unstoppable, graceful. You may never see it, but you can feel its balance, its promise. The universe, it says, may not only end, it may also begin, again and again, in ways we cannot yet grasp. This quiet goodbye is not the closing of a door, but the soft folding of a page. We set the thought of white holes back onto the shelf, knowing it will wait there if we ever wish to return. Like many of the cosmos's mysteries, it is less a puzzle to be solved and more a companion to be carried, a reminder of how vast our questions can be and how soothing it is to rest inside them. And so, white holes slip back into the horizon of thought, fountains receding into silence. They leave us with balance. For every abyss, a fountain. For every ending, a beginning. For every shadow, a light. Dear dreamer, we have traveled far tonight. From equations to metaphors, from physics to imagination. We have followed an idea that may never be real, and yet has offered us real comfort. The comfort of symmetry, of hope, of wonder. White holes may never blaze in our skies, but they blaze in our thoughts. They remind us that even the impossible can have meaning. They remind us that beginnings are woven into endings. They remind us that mystery itself is part of the gift of being alive. So, as you close your eyes, let yourself be carried not by answers, but by questions. Let the fountain of imagination flow gently through you, reminding you that you are part of the universe's unfolding story. You are the child of stars, the echo of expansion, the dreamer of possibilities. Rest now, knowing that even in the vastness of the cosmos, there is space for you. Rest, knowing that even the darkest night is balanced by the thought of fountains yet unseen. Rest, knowing that to wonder is enough. Good night, traveler. May your sleep be deep and kind. May your dreams be fountains of light spilling outward into the horizon. And may you wake renewed, as if you too had stepped gently out of a white hole, beginning again in the morning's quiet glow.